All right. Hey, everybody. Welcome to today's plant clinic. I am so glad to have all of you back. We're just going to take a few minutes to let everybody get signed on. Let's see here. I'm trying to do something new today with YouTube, and it's going to take me a second. So I'll work on that once we get, once David gets going. For those of you who are on Mary Kirk's class at noon, welcome back. For those of you who are joining us for the first time today, we're so glad to have you. David has got a session geared up today on fertilizers, which I know is a topic a lot of us don't understand a lot about. So this will be very informative, I know, for me and probably for most of you. So David, I want to turn it over to you really quickly, but I just have a couple of notes for you guys as you're logging in. Because this is a webinar, if you're new, we can't actually discuss with you during the class. So send your questions in via that Q&A box. I'll be monitoring that during the class. And we don't send up follow-up emails after this class to everybody who attended since we live stream. So if you have questions after the class, just feel free to email me or call the plant clinic, and we'd be happy to follow up with you guys with any questions you may have after this class concludes. So David, thanks as always. I'm going to go ahead and turn it over to you and work on getting us going on YouTube.
Okay, excellent. Well, good afternoon, Sally. Good afternoon, everybody. Thank you for joining me today. I heard Mary Kirk's class went really well earlier. I'm going to go pretty much totally different direction. We're not so much talking about pretty flowers or garden styles or anything like that today. I just decided I wanted to really kind of go in depth on just the topic of fertilizers. Part of this because, hey, it's winter time. It's, not a whole lot going on at the plant clinic right now. So I've got the no other pressing issues there. And I think there's just a lot of misconceptions and different ideas and tremendous amount of marketing and a whole bunch of stuff that goes with fertilizers, what they are, what they're not, how to use them. So this can be a little bit of a deep dive into that topic. Try to stick with me. As always, we love hearing from you, taking your questions. So I've got this broken in kind of roughly 2 sessions where I'm going to talk about a little bit about fertilizers, what they are, what they're not, in a very general form. We'll take time for questions, make sure we're all together on the same page, and then we'll go back and I'll go into more detail on some of the different formulations and stuff. So with that, that's kind of the agenda today. And with that, let's go ahead and just kind of kick this thing off. So just a real quick review kind of thing of just plants, and how they grow and stuff. Basically, plants are truly amazing organisms in that what they're doing is they are capturing the sunlight, using the sun's energy, and also taking water up through the roots, and they're combining basically the carbon and the oxygen from the air, taking the water, and through photosynthesis, converting that into sugars, converting it into food. So what I'd really like to emphasize from the beginning is we do not feed plants. Plants are capable, they produce food, and the plants in turn feed us. So it's the other way around. We are totally, completely dependent on the plants, the air we breathe, the food we eat. At some point in the food chain, starts with photosynthesis and in the plant. So they do that again through this miraculous development of photosynthesis. And as they're producing those sugars and carbohydrates for their food, they're also putting that down into the soil and feeding all the microorganisms that are there. And at the same time, all the herbivores and the insects and everything that comes to feed on that plant, which in turn starts the food chain going. So fertilizer is not plant food. Plants don't actually eat fertilizer. What we're really doing is just providing necessary nutrients. And specifically, what I'm talking about today is this little part right down here when it says "and minerals," because what I refer to as the non-fertilizer elements here, the oxygen, hydrogen, carbon, the plant gets that from the oxygen and from the water, but the minerals that the plants need to live, grow, and thrive is what we really kind of lump together under this sort of title fertilizer. So if we look at it here and we say, okay, hey, there's 14 essential elements or nutrients that the plant must get from the soil to sustain healthy growth. And in our soil, in an old age mineral soil like we have here in the Virginian area, it tends to be very high mineral content, high nutrient balance, but it really needs to get all 14 of these nutrients. They're all of equal importance. If you take any one of these minerals out of the equation, the plant's growth and productivity begins to suffer, right? So they are divided into these three groups, really based on the quantity that they use. So this isn't like one's more important than the other. It's just a matter of how much they need by volume. So what we refer to as the macronutrients here: nitrogen, phosphorus, potassium. Plants need a lot of this, relatively speaking, these three. The secondary nutrients, the magnesium, sulfur, calcium, they also need in significant quantity, but not as much as the first three. And then micronutrients. They just need tiny, tiny, tiny little bits of these micronutrients, but without them, again, the system just doesn't function. So again, when we talk about fertilizer, what we're really talking about is providing these minerals for the plant to assure good, healthy growth. Taking this just a little step further, we're going to concentrate on the macronutrients, the stuff that the plants need in relatively large quantity, right? So nitrogen, which you can see there, it's essential in building proteins. It's essential in every living cell. You need your nitrogen. Plants need their nitrogen. All life needs nitrogen in there to grow and to live. Phosphorus, which is very important in energy transfer processes in the plant. So wherever there's a lot of cell division taking place, we talk about this, the growth meristems. These are kind of the technical terms, but these are the growing points where cells are dividing and multiplying. So that could be down at the root tip. It could be at the branch tip. It could be when fruit's expanding. So wherever that growth is concentrated and high energy demands are there, phosphorus is a key element in that transfer of energy. Potassium, which is very important in some of the metabolic pathways within the plant. It's also has a lot to do with, you see this in the cell membranes and the transfer of nutrients back and forth and across these semi-permeable cell membranes. So again, I know this is all the kind of technical stuff, but I think it's really important for us to understand when we use this word fertilizer, exactly what we're talking about. It's not medicine, it's not food. Again, I think of this more similarly to saying it's sort of like taking vitamins. We may take vitamins to supplement our diet to make sure that we get all the minerals that we need, to live a healthy life. It's the same thing with plants. They derive these 14 essential minerals that they need out of the soil. And we as gardeners, sometimes just to help them along the way or to manipulate the plant growth in some way or to make up for deficiencies, we may choose to go back and add some additional nutrients to the soil. So let's kind of start bringing this down to what really happens like when you come into the garden center, when you go shopping for a fertilizer. So this is all regulated by law. So you'll see this very consistent across all brands. In fact, this exact fertilizer, the Merrifield Starter plant food here, we don't even have it in stock. We've been out of stock on that for a while, but it serves as a good example when you're looking at just a generic fertilizer product, how you understand and know and look what you're looking at. So if you look at this product, they will always have these three numbers, in this case, 6, 12, 8. And what happens, this represents a percentage by weight. So this particular fertilizer is 6% nitrogen, it's 12% phosphorus, and 8% potassium. So you'll recognize those are the three of the macronutrients, those 3 of the macronutrients, what the plants need in big quantity to maintain really good, healthy growth. So they're always in this order. They're always represented as percentages by weight. I made a little note here, and we'll come back to this later, more detail. But the nitrogen, this first number, and here, this 6%, it's a mobile mineral, mobile nutrient. It doesn't stay put in the soil for a long time. It's constantly cycling through the environment. Phosphorus, this middle number, which tends to be an immobile fertilizer, you put it in there and it basically stays put. And potassium is kind of intermediate in its mobility of how it actually moves through the soil, moves through the environment. And we're going to come back to all of this here in just a minute, kind of start tying it together. So again, that's your N, P, and K, or your nitrogen, phosphorus, and potassium, the 3 macronutrients that all plants need. So when you're figuring out, well, does my plant need to be fertilized? Or what fertilizer should I be using? To understand really what those questions are. In the ideal scenario, we would have a soil test which measures the existing nutritional value of your soil. So for example, it's really great if you are a new homeowner and you don't know the history of this soil and you don't know what's been done as far as fertilizer applications or what's been grown there previously or any of that information. You can take a soil sample, have that evaluated at a lab, and what they're doing is they are actually going through and they're measuring how much phosphorus and potassium and calcium and magnesium, zinc, copper, molybdenum. They are measuring all of that, putting it into a report, and based on what you have, they can recognize if there's any deficiencies or imbalances in the soil and can make recommendations on how to correct that. So that's really the very best way to understand which fertilizer is needed in your garden. If we take that just a little step further, they also measure the soil pH. The pH is basically to determine if the soil is acidic or alkaline. And these things, again, it's all going to start coming together here real soon because the pH of your soil has a huge influence on what's available to the plant. So the way you read this chart is right here. The pH is a scale that goes all the way from 0 to 14, but this is basically the meat of it. So right here at 7 is the middle. That is neutral. If I'm going above that, if I'm going 7.5, 8, 8.5, and I'm going this direction, the soil is becoming more alkaline. If I'm going down the scale, 7, 6, 5, so on, the soil is becoming more acidic. When you look at this, I'm looking at phosphorus here, right? The second one, make sure everybody's kind of following along here. So we said phosphorus, which is, again, one of the macronutrients. It's the middle number on a bag or box of fertilizer. And when I have a pH that's right here in the 6.5 to 7.5 range, see, this is indicating phosphorus is readily, easily available for the plant to absorb. If I start going below that, if I start going down into pH of 5.5, 4.5, as I go down this scale, that phosphorus is immobilized. So it's still there. The phosphorus is there, but now it's not in a form that the plant can absorb it. If I start creeping up the scale, my soil becomes too alkaline. You'll see the same thing happens where that phosphorus is immobilized and it's no longer available. So these things are kind of intertwined together. It's number one, what nutrients are existing in your soil, and number two, are they readily available to it based on the pH? And a soil test is really the very best way to go about answering that question. So I think this is, at this point, I'm going to take a little break because I've gone through all this technical stuff. I want to see if we have any questions on this. And what we'll do following is get into some of the details of the actual fertilizing.
Okay. So y'all, if y'all have any questions, please feel free to go ahead and send them in and let us know throughout. David, the question we have right now is about bulbs and bone meal, using bone meal for bulbs. So I don't know if you want to get into that or hold that for a little bit later. Oh, here. Oh, can we get an email of that chart, or do you know where that's available?
Of the pH chart?
Yes.
I stole that off of Google. I don't actually have permission to use it.
All right. So
But
we'll
you can do Google pH chart, Google images, you'll find it.
All right, ask Mr. Google for that one. How often should I test the soil?
Good. I wanted to talk about soil testing, and I know I'm hitting all this technical stuff to begin with, but that's the way I wanted to run class. So there are different ways that you can test the soil. This is the preferred way, what I call sort of the gold standard. This is through the soil testing lab down at Virginia Tech, and there's really two parts to this. And I am going to answer your question about how often, but you reminded me I wanted to go through this. So there's really just two parts to this, right? The little white part is a box, self-folding box, and then the green part is actually just an information sheet that's filled out. So if you want to do a soil analysis, you can collect soil, you go around your yard. Let's pretend you've got a vegetable garden that's 10 by 10. You would go around that vegetable garden and maybe collect 5, 6, 7 small samples, mix them up together. So now that's a representation of the entire vegetable garden. You put it in this little box, the little self-folding box.
And are those available at the plant clinic?
So we have these at the plant clinic. They're also available, I know, at Fairfax County libraries, and I think it goes a few other counties throughout Virginia. If you happen to be in Maryland or outside the state, that's a little different setup. But what I'm talking about, this is available to how it's done in Virginia, just for clarification. I think outside of that, they may go through private labs, and there are private labs that do that. So a basic test that gives you the information I just talked about to in-state residents costs $10. So it's easy peasy. You mail it down there. About a week later, you get a report back with all this. As far as the question came, how often do I need to test the soil? If you have, I wonder if I have, did I show that slide? I didn't go. So that soil test I had up on the screen there, the pH of that soil, I'm going to go back to this. I'm taking a long time, this question, but it actually brings up a good point.
While you're bringing that up, when you're saying to send a little bit of soil, how much is that? Like if someone's going to grab soil out of their yard?
You want to fill this box.
Okay, so the box will be like, fill the box up. It's pretty self-explanatory.
So this box is about 2 inches by 3 inches to give you an idea of the volume in there. So the box would be full. They are actually only going to take a very small subsample out of this box. And they do a great job. They take a little subsample of this to run the test, but they hold on to the original sample for about 30 days. That way, if there's something questionable, if there's something malfunction, you need to follow up, they can still go back and do a second sample for quality control. But yeah, this box needs to be filled. So this report, that's what I blew one up here big enough for me to read, because you probably can't. The pH on this particular soil, if you could see it, this is a pH reading, comes back at 4.6, right? So 4.6 puts us way down in the scale here, right? So based on that pH reading, their recommendations are saying, hey, you have to add 215 pounds of lime per 1,000 square feet. So what I'm going to be doing is incrementally, I might put down, every 30 days, maybe I make an application, I make an application, I make an application until I get to that desired pH. So back to your question, how often do I test my soil? If I'm in this process where I'm actually trying to change the soil, if I'm trying to elevate the pH or change the phosphorus, I might do a soil test, wait 6 months, 12 months, do a second soil test and kind of see where I am. If I'm still not where I want to be, maybe I made more additions. I wait 6 to 12 months. I do another soil test, see where I am. If I have soil that's in good condition, I've been gardening and I'm happy with the nutrient values, everything looks good, I might just live with that for 3 to 5 years and then just on routine maintenance kind of go back. It could literally even be years later to see where I stand on that. So how often you test really just depends on what your circumstances are, where you are in this kind of whole process. All right, that was a long answer. Anything else?
Sorry, I muted. My dog keeps starting to bark, so I'm trying to keep her muted. All right, next question. So is the range of 6 to 6.5, I think it was the range in those red lines, is that a range for all the nutrient categories? Like, is that your kind of general recommended pH?
That is the general recommendation for most plants. Now,
Okay.
plants have evolved in sort of different environments. So we all know there are acid loving plants. So you have things like blueberries and rhododendrons and azaleas and everything. They actually need to be further down that scale. They might be down in that 4.5, 5.5 kind of a range. So yeah, that's 6 to 6.5, for most vegetable gardens, flower gardens, landscape plants, even lawns, most plants are going to be happy in that area, but there are some then like roses and lilacs and lavender that might actually want to be higher in that range, up even to 7 or above. So it does vary with the plant, but yeah, 6 to 6.5 is a good ballpark figure.
Okay, that actually ties in. So one person asked, the chart showed phosphorus green is green again above 7.5. So phosphorus becomes available again at that level, but most plants don't want to be that alkaline.
Right, because then if you go to either extremes, you start seeing nutrient toxicities develop. So you can say, hey, phosphorus comes more available, but then you can also get in things like, I think it's boron, for example, and some of these others become to the point there's so much of it available that it becomes toxic. So yeah, you kind of don't want to go to those extremes unless the plant's really specifically adapted to those realms.
Got it. Okay. Last question on soil testing. Do you need to put the soil box into another box when you mail it?
Yeah, when I do it, I use those heavy padded envelopes. Those little Tyvek envelopes are things that are made for packing and shipping. Those work pretty well. But yeah, the form, your check, the box, all that goes into a shipping envelope or a box and sent down to the soil testing lab.
Great. All right, that's it for soil testing.
Good. There are do-it-yourself kits. We sell them. We have them. Just real quick, you can get like a pH meter, which gives you sort of a quick ballpark reading. This is like a little science project where you can take some soil, some distilled water, shake it up, and it's got a color key on that. So these can be useful. I have used them and I have tested them against the university test service. They get you in the ballpark. It's not as accurate. And like I said, what I really like the university test because they do all the quality control measures. That test is being done right. And way more accurate, and you get the recommendations back. But if you don't want to go to the shipping, the mailing, and just as convenience, these do-it-yourself kits are available, and they certainly will get you in the ballpark. So let's say you've been through this process, and you say, hey, I did my soil test, got my results back, got pretty good grip now on what I'm looking for based on these test results. I sort of understand what I'm doing. It's not, again, people, their tree or their shrub or their flower is not doing well. What I find is like the first thing they do is they water it. If that doesn't work, then they fertilize it. And if that doesn't work, then they come in to see us at the plant clinic. I'm just trying to say, this is like taking a vitamin pill. It's not going to cure a disease. It's not going to correct a watering thing. But it does provide that we have the correct nutrition for the plants. So that's all kind of my background, and I'll hit this stuff pretty quickly, and then I love just get more and more questions on this. So that leaves you down this path saying, okay, well, Now I've done all this homework. I got a better grasp on what I'm looking for. You go to the store and what do I want? It's just like anything else in our world. It's just overwhelming, the number of different products out there, and this is just, again, what we do, commercialism, start packaging and selling all these different products. And then you come in, and oftentimes you can leave more confused than where you started. So I will put these fertilizers in two broad categories and that's really based on the nitrogen. If you remember that first macronutrient, the nitrogen, that is really the key element. I had talked about that being mobile because nitrogen, it can exist as a gas, which it's in the air that we breathe. Nitrogen can be soluble. It can be literally mixed with water, and nitrogen can be immobilized and tied up and bound up with an organic matter. So nitrogen is just constantly cycling through our environment. In fact, when you're doing these soil tests, they don't even measure the nitrogen, because I could take a soil test today, before it started raining. I could take a soil test, 2 days from now after raining, and I will get different nitrogen readings. So they don't even bother measuring it. They make their recommendations just based on lab analysis and experience and knowing the plant. They're making recommendations based on that, not what's actually in the soil. Because nitrogen, and this again is our fertilizers, it's going to be either what I'm calling quickly available. So this would be an example of nitrogen where that fertilizer, it may go into solution, it goes into water right away. Hey, I take it, I mix it with water, pour it on the plant. Plants will absorb that nitrogen within a period of 24 to 48 hours. So that's where you get this very quick green up, this very rapid response, but it doesn't stay there. It's come out the solubility of it. So within 48 hours, that nitrogen has again continued to wash into the soil, or it's volatilized, it's gone back into the atmosphere. The nitrogen's not stable there. It's constantly moving through there. And so with that, that's what it has, this kind of short residual. This is where we get into problems where you over fertilize, like, hey, tablespoon was good, let me put half a cup in there. Well, you can get so much in there that you injure the plant with it. But this is also reflected in the costs. The other side of that, the exact opposite, is so what we call slowly available nitrogen. Because it does not immediately go into solution, it has to go through some type of further chemical breakdown. You may not see an immediate response. You might put it down and you just see this very gradual response of the plant, slowly greening up. But it also means that it's going to last longer, so it sustains that color or that green growth over a longer period of time. With that, that's good because it's less risk of it. It's not going to readily volatilize or wash away. It's going to be there for a longer time. There's much lower risk of injuring your plants or the environment with it, but there's more technology goes into it, so the cost goes up. So examples of that, putting this in real life terms that be easy to follow. These are what we call water soluble fertilizers, and there's many, 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 many others. This is just like a picture screenshot off of our shelf. Well, so these are examples of fertilizers that essentially dissolve in water, apply to the plant. You get this immediate response out of it. This top row, which is called Dynagrow, just as a brand name, a very good fertilizer, but it was designed specifically for hydroponic gardening. So that makes perfectly good sense. The Jack's Classic series, which used to be Peters, is Jack Peters. They went through name changes and reorganizations and stuff. That's a water soluble fertilizer. These are the powders or the liquids and things that you mix with water. And that's, so you get this very quick, instant, but short lasting result. Commercially in production systems, that's a lot of what's used because that's time is money and that's what we're going for. They're keeping the cost down, the products, getting a quick turnaround time. and intensively managing those plants to get them out the door and get them for sale. In home gardens, we may want the same benefits that go to that. I think of this mostly with annual plants. If you've got hanging baskets, potted plants, annuals in garden. Annuals, I think of them like energy hogs. And it's like, hey, if I keep them fertilized, keep them growing, just keep them blooming all season long. And you saw there's specific ones. Hey, you might have a specific one for orchids or another one for flowering plants, a different one for vegetables. But when you read the instructions, they usually tell you they have to be applied about once every week or two. I'm conservative on that, so I'm usually saying, hey, apply them once every 2 to 4 weeks because I don't want you overdoing it. So they're excellent. They get you quick response, but you have to keep doing it. The other side of this spectrum goes into what we call the slowly available nitrogen sources. And these just all this chemical nonsense. These are just examples. This urea formaldehyde, IBDU, sulfur-coated urea. This is just different technology that has gone into making that or preventing that nitrogen from becoming soluble and allowing it to gradually break down over a period of several weeks or even months. And by doing that, it's less labor involved because I might fertilize it once and that could last me 6 months, 9 months, 2 months, depending on the product. You can kind of program it that way. You don't have to worry about the runoff of it, possibly getting into contaminating water, much lower risk of overdoing it, but the cost on these products kind of tends to go up. So what formulators do, again, this is just an example, our Merrifield Premium Lawn Food, how this all translates. And everything I'm telling you is on the product label. It's in the fine print that nobody ever bothers to read. And you don't need to read it. That's our job here, but it's on there if you want to dig into that. So you look at 26012, again, like we talked about. So this is 26% nitrogen, 0% phosphorus, 12% phosphate. 12% potash or potassium. So these are the 3 macronutrients that we've been talking about, percentage by weight. In this fertilizer product, we've made it 50% slow release. So what that tells you is half of that nitrogen of this first number, this 26%, half of that, you put it down, you water it in, boom. I get within a day or 2 or 3, you start to see your lawn improving, getting a darker green color. But the other half of it is a slow release form. And so that breaks down gradually over a period that might be 6 to 8 weeks. So what we're trying to do in this case is it's not always one or the other. We're blending these together so I can get both a quick, immediate response, but then also get a much longer lasting one. So these things are not exclusive of each other. In fact, most of the time they are mixed or blended together. So the slow release fertilizers are most frequently used on plants that have a longer growing season. So when we get into trees and shrubs and lawns and perennials, this is where we tend to go more towards the slow release fertilizers because they have a longer growing season, and we can get all the benefits that come from that sort of extended release rate. Everything I've said to you holds true for organics as well. It's just up until now, I've been talking about fertilizers that are basically manufactured in a factory where raw materials come in, they're processed, and then they come in concentrated forms and go out. There's a huge amount of interest in organic fertilizers that instead of being processed in a factory, this is taking raw natural materials that could have been, a lot of them are based on manure. So we're talking about byproducts from the poultry industry, quite frankly, like meat packing, even the human waste. So we're talking about manures, byproducts like alfalfa meal, soybean meal, feather meal, bone meal. Most of these, because they're organic, they have a lower concentration that goes with them. They tend to be of a slow release nature, longer lasting. I put in there just as note, their effectiveness is very much dependent on the soil temperature, because you've got bacteria and fungi in the soil that are decomposing, they're digesting and breaking this organic matter down and releasing it back to the plants. So organics are fantastic because we're using recycled products. We're feeding the soil, feeding the microbes in there, which in turn are feeding or fertilizing or providing those nutrients to the plants. And they tend to be very long lasting with very little risk associated with it. So a lot of times this is often focused towards growing edible plants, vegetables, herbs, fruit trees, and so on. That's my fertilizer talk. Kind of a lot of stuff there to digest. I realized I just, kind of went down the rabbit hole on the fertilizers and soil chemistry. May not be your thing, but I enjoy wanting to talk about. I did want to include one pretty picture in my slideshow. So this is it. We're not here yet, but hopefully we will be soon. Spring seems to be approaching rapidly, but I didn't want to leave you without a pretty picture. So I'm going to stop here and see if we have any questions at all, really on any gardening topic, but really focused on the fertilizers. All right, Sal, we don't hear you. I think you're muted.
I'm sorry, my dog is being so noisy today. I keep having to mute myself. She's usually so good.
Yeah.
So, okay. The first question, this may be a question for bulbs specifically. When I plant the bulbs, I use bone meal. 5 to 10 years later, what should I use and how? Or should I dig them up, separate, and replant with new bone meal?
Okay. So bone meal is a really good organic source of phosphorus. That middle number we talk about, the phosphorus, which tends to, like I said, it concentrates on the growing tips. So people love it, for things like, bulbs and flowers, because it tends to reveal itself with better flower production, better fruit production, good strong root development. So it adds all those benefits to it, and it is very long lasting. So I would say if you're using it with your bulb planting, that should provide enough phosphorus, for at least 5 years. If you've had time go by and the bulbs are still performing well, there's no reason you need to lift and divide them. However, if you start to see where their flowering is diminished, let's pretend you've got a clump of daffodils, and you're going from having 12 down to 10, down to 8, down to 6. If you're kind of like regressing, that's a pretty clear sign that you need to lift the bulbs, divide them, separate it. And at that time, yes, I would recondition with more phosphorus, whether you do that with bone meal or superphosphate or rock phosphate. That's where we go into. There's many different sources, and bone meal is fine.
All right, next question. We have a couple people asking about this in general. If you're buying and putting into the soil compost, mushroom compost, lobster compost, any of the variety of compost products that we sell, do you still recommend soil testing and fertilization, or does that kind of cover your gardening needs?
So it's hard to answer that question without having an initial soil test. I still think that soil testing is worthwhile because you're going to get kind of a baseline nutrition of what's in your soil to start with. They also do offer an organic matter analysis on there. I think you pay $2 or $3 extra, but for that additional fee, they will literally measure the amount of organic content that's in your soil as well, which is really good information on understanding how effective that composting process has been. So I would still say, yes, do a soil test, kind of get that baseline information, but you can meet the nutritional needs of most plants with just adding compost. In a vegetable garden, because they're producing more and you want to make sure that you have sufficient nitrogen for the plants, you may want to also incorporate some type of manure-based compost, because this is where I say if you're dealing with composted shellfish, composted cow manure, something like that, that's manure based, that tends to have a little higher nutrient value. But yeah, you can absolutely do this all organically. You can do it with compost, but a soil test is still worthwhile to kind of know where you are in that whole spectrum.
Okay. All right, next question. How long is a tree in your landscape considered to be a young tree?
When we use the term, and then that word has a lot of different meanings to different people. When a lot of times when I'm using it in the retail nursery trade kind of a thing, what I'm really trying to figure out is how long ago was it planted? Is it young relative to its establishment age? So has it been planted 1 year ago, 2 years ago, 3 years ago? Because that gives me an idea. I know about how long it takes for that tree to get reestablished. So a lot of times I'm asking you from sort of where the planting date is. If you are looking at just a tree that's growing in the forest, then that is probably relative to what its expected mature age is. So if you look at an oak tree that we know in a pristine, beautiful, prime conditions might be able to live to be, let's say, 350 years old. So relative to its, well, I'll call its mature age, you could be looking at a 100-year-old tree and I could still be calling it young. So again, those terms are a little bit subjective, and it's and I have fun doing that. But like I said, I would say it is, we're probably talking about in the nursery trade or landscape industry, kind of where is it in its establishment phase, and young is probably going to mean like kind of like within the 5 years or so of planting time. But that might be a tree that we want to live to be 90 years old. So then it could still be called young.
Got it. All right. What is the soil temperature for slow release fertilizers? Is there like a time you're supposed to use them, or a correct temperature?
So they have different mechanisms that go into it. What happens is a lot of your slow release fertilizers, like any of the organic products, and even some, what, try to figure out any easier way of saying this, but what we call methylene urea formaldehyde, IBDU. A lot of those fertilizers, they actually require bacteria in the soils to activate it. So like when we're putting that fertilizer in the soil, it sits there, and then it's bacteria in the soil that go after, because they need their nitrogen. They're at the bottom of the food chain, so they go after it, they break it down, and it's then the bacteria that release it to the plants. And those bacteria are temperature dependent. So this is where I'm saying kind of we're getting down into the real details on it, but that's again what I want to do today. The bacteria, their activity pretty much comes to a stop, when our soil temperatures hit 40 degrees, and they're really sleepy and slowing down at soil temperatures of 50. So most of those products are plant available when our soil temperature is about 50 degrees and above. But again, that is influenced by temperature. There are some, and these are in the synthetic world, where it's more released based on moisture and has more variable in there. But I'm going to go with 50 degrees and above.
Okay. We are getting a lot of questions about specific fertilizers, including the one next to you, the orchid one.
Yeah.
They have multiple. So here's a question that I think we'll start with. Is it worth getting a variety of specifically focused fertilizers, flowers, vegetables, etc., or is there a general fertilizer that I can use for everything?
So you can get just a general use fertilizer. Most of this stuff is marketing that goes into this selection. Now, when I say that, orchids are different because again, orchids are epiphytes. They don't have these relationships with bacteria in the soil and stuff. So with an orchid fertilizer, it's a little bit of a different story. They absorb their nitrogen straight into the plant in the form of ammonia or nitrate. So one of the things that's nice, like with this fertilizer I'm showing, is that this is literally, it's just spritzed right onto the plant. it's in a plant available form, and your orchids will respond differently to it. So there are times when you may want to tweak things like that. If I look at something like tomato tone, right? Tomatoes generally take up more potassium. So what they've done is they've taken an organic fertilizer, because most of us want to go organic in our vegetable gardens. This one is what they call a 3-4-6 analysis. So it's got a little bit higher potassium. So you can play with these, and that's what they do. They kind of fine tune it. But most of the time, you can just get yourself an all-purpose fertilizer. And I'm not, this is just one example. These are not recommendations. It's just like teaching tools. But see, this is what they call, this is a 10-10-10. It's the ratio 1-1-1, 10% nitrogen, 10% phosphate, 10% potash. This is what's called an all-purpose fertilizer, equal balance of nutrients across there. The thing that I'm not excited about this exact product is this is 100% water soluble. But if I could take this and get something that might be more like a 50% slow release, you know, that's going to meet a lot of your needs right there. So you can, just you can go with an all-purpose fertilizer, but then I encourage you to have fun with gardening and tweak some of these things and play around with them, and you can get a little different results, and it's fun.
Okay. All right. I know we're running out of time. I've got a question here, though, that I think we should address. Are there specific different times of year to fertilize different perennials, shrubs, or trees, or are there some generalizations? Do you have any tips for that?
I do. I meant to talk about that in my slides and I forgot. You would, if the more you dig into this, the more I dig into it, the more I learn. I'm amazed at how little we really know about all of this. What I would tell you is, in my opinion, assessing all this stuff, is that I just want to, and this is Will Jones, I want to time my fertilizer applications with the growth cycle of the plant. So what that would mean is, for example, trees and shrubs. These plant, a lot of our trees and shrubs, they're going to start growing in April and May. I would like to fertilize them right at the beginning of that growth season. So, and this is just general, I'm just going to say trees and shrubs. Hey, if they start growing in April, May, I want to have that nutrients that's there available to them, as we go in that April, May, June time period. If I have an azaleas are terribly common, right? Azaleas, let's say they flower for us in April and they start growing in May. So I want to have my fertilizer there for them when they start growing in May. So if I'm growing a cool season like pansies, I want to fertilize that. They're growing during the cool weather. So I want to fertilize them in the fall or the early spring. So I let the plant kind of dictate that time that's going in there. So it's going to vary with plants, but you just pay attention to your plants, and when they'll tell you when they're ready to start growing. To me, that's a good time to fertilize them.
Okay. All right. I see we're at 2:48, so I want to go ahead and get us wrapped up, David. I know I can see we've got 6 or 7 questions that we weren't able to get to, you guys. So I just want to say, if you think of anything, if you don't have one of those questions, please feel free to follow up if you think of something later. If you have those questions, please feel free to email me or call the plant clinic or email David. I'll put you in touch with David. If you email me, that's fine. And send your questions. And I am sorry we couldn't get to everything today, but this is lots of questions on this topic, which is great. It's just more than I think we had time for. So, David, do you want to wrap up with any last bits of information? Or
I do, because one thing that I hope you kind of pieced together today, the soil, the native soil basically provides nutrients for most of our plants. I mean, you look at trees growing in a forest, leaves come down, they degrade, they break down, there's minerals in the soil. It's just, again, I say, like, in an ideal world, we would get all our nutrition. I always think, hey, I can get all the minerals that I need just from eating a good, healthy diet. But you know what? I don't eat a good, healthy diet, so I still take some vitamin supplements. But this stuff is not life or death. with the plants, but you can improve their growth. And like I said, maybe I'll just leave it there and tell you, hey, stop by the clinics. Again, we can help you decipher all this. There's no rights or wrongs in it. But anyway, thanks for joining. I think we're taking a break. The next one, I'm going to be away for a little bit. So then it'll probably be about 4 weeks before I'm back on the air with you.
Yes. Yeah. So we will not have Plant Clinic on, I think it's March 2nd. But we will be back on the 16th of March. So for those of you who usually attend every other week and are regulars, just know we won't have Plant Clinic in 2 weeks, but please feel free to send us those questions, send them to me. I will forward them on to David. So you will still get that information, or you are always welcome to actually just call our plant clinics. David works at the plant clinics, and we have people at plant clinics at each of our stores. So thank you, David. This was super informative. I have not actually learned a whole lot about fertilizer in my time at the store. So this was good information for me. All right, everybody have a good day. Thanks, David.
All right. Thanks, everybody.
All right. Bye.